We are still on using trigonometrical ratios in solving right angle triangles. Remember, we are now looking at special angles. On the screen here, we are going to apply the trig ratios of special angles in solving 3 problems. We are required to find the length of the sides marked M and N. So we are looking for the sides marked M and N. Let me change the color of my marker. M and N. So we're going to find the side labeled M, N there. Likewise, in this other diagram, and also in this other one, M and N. There. So let's set out and look at the first. How do I find the length of the sides marked M and N? Of course, we can say, let's try Pythagoras theorem. And Pythagoras theorem will say, oh, the square of the hypotenuse, M square, is equal to the sum of the squares of the adjacent sides, 10 square plus N square. But we can't use this. Why? Because we have 2 unknowns. We have M, we have N. So run back to our trig ratio. Now, I decide to find M first. You can decide to take any other one. So I want to look for my M first. Now, since M is facing the right angle, that will be my hypotenuse. And then I need a side I know. I can't take 2 unknowns. So I take the side with length 10. And as far as this side is facing the angle that is given to me, that is 60, so that side will be the opposite side, since it is opposite to our considered angle. So I say, oh, opposite and hypotenuse, what do I use? Oh, that reminds me of sine. From where? From SOH CAH TOA. I know that sine combines opposite and hypotenuse. So I say, okay, let's run along. This is sine 60 equal to opposite 10, hypotenuse M. What is sine 60? I can recollect sine 60 must be root 3 over 2, because I know sine 30 is 1 over 2. So, okay. And then this is 10 over M. I cross multiply here. That gives me root 3 times M. And 2 times 10 will give me 20. Okay. Let's divide this. To get my M, I simply divide both sides by root 3. And that gives me 20 divided by root 3. M cannot be left this way. Why? Because we are not allowed to leave a fraction with the denominator as an irrational number. Root 3 is an irrational number. So what do? I'm going to rationalize. How do I rationalize the denominator, which is irrational right now? I'll simply multiply both the numerator and the denominator by that value of the denominator, that is root 3. Now doing this will give me 20 times root 3, 20 root 3. Now root 3 times root 3 will just give me 3. And that's it for M. We can move on. Yeah. That's a summary of that. Same thing we had in the last screen. Now next we look at how do we now get N. So okay, I can now apply my Pythagoras if I want to, but let's still go ahead using our trig ratios of special angles. So I'm going to use N, and I'll combine it again with 10. Remember, our 10 is facing 60, so that is our opposite. And N automatically will be the adjacent, because M is the hypotenuse. So say, next, tan 60 is what? Tan 60 is opposite 10, adjacent N. What's tan 60? Tan 60 is root 3. So straightforward. Go back to the table we had earlier in the last clip. N. We cross multiply here. We have root 3 times N is equal to 10. Dividing both sides by root 3, you have N equals to 10 all over root 3. Of course, I can rationalize again because I don't want to leave the denominator as an irrational number. So I just multiply both numerator and denominator by root 3. That is the irrational number itself. So that gives me 10 root 3 divided by 3. That's it for the first problem. Let's move now to the second problem. That's a summary of for N. Let's advance. Now the second one here, you can see it's a right angle triangle. At the same time, it's an isosceles triangle. But let's not look at it from that angle first. Let's see treat using our trig ratio or special angles. We have both angles 45, 45. I decide to find M first. I'm going to combine M with the side 6. I'm not combining M with N because both of them are not known. M, again, in this triangle is the hypotenuse. 6 is facing the angle 45. So let's call that opposite. And therefore, it means this will be adjacent. Since I want to look for M first, I want to look for M. That means I will be combining my hypotenuse with the opposite. And obviously, you know this is going to be what? Sine. So I say, okay, sine 45. Where are you? Sine 45 is equals to opposite over hypotenuse. 6 is the opposite. Hypotenuse is M. Sine 45 from our table the other time is 1 divided by root of 2. Remember that sine 45 and cos 45 are equal. So you always have 1 over root 2. And this will give me 6 over M. If I cross multiply here, my M will come out on the left hand side as just M. And then I multiply 6 by root 2. And I have it as just 6 root 2. So straightforward in this case. So our M is 6 root 2. Next, the third problem. That's the summary of what we've just treated. Sorry, I'm looking at the other slide. Now, if you can see what we've done here, we looked for N first, and N, we took here. N, remember that this is the opposite, and this is the adjacent. So, this is solving for N. I would say tan 45 is what? Opposite, N, all over adjacent. Okay, sorry. I think we are looking at it from this side. It's still the same thing, anyhow you are looking at it. You can take it this way. Okay, let's solve our own way. Tan 45 is what? If I'm using this angle, this is the opposite, so that will be 6. Whichever of the angles you use, you still arrive at the same thing. Tan 45 is equal to what? 1. And this is equal to 6 divided by N. If I cross multiply here, I have N times 1, which will give me N. And then 6 times 1 will give me 6. Now in this other, in the one that is solved here, actually this other angle was used. So this became the opposite, and this is the adjacent. You still get the same thing. So tan 45 was therefore opposite, which came out as N, and then the adjacent is 6. And then of course cross multiplying the tan 45 is 1. Cross multiplying we have N equal to 6. Now in solving for M, instead of applying again using the trig ratio, we decide here to apply Pythagoras theorem. There are so many ways to kill a rat. M squared is equal to N squared plus 6 squared. Why? M is the hypotenuse. And then the rule says the hypotenuse square is equal to the sum of the squares of the other two sides. Since we have obtained N as 6, we can just fit that in. And that gives us 72. M is therefore square root of 72. And that gives me here 36 times 2. I'm trying to play this out. Square root of 36 is 6. And then we have 6 root 2. Which is the same thing we had earlier when we just applied what? Our SOH CAH TOA. Now let's take our time and look at this problem. In this figure, if you look carefully, you can see 2 right angle triangles. There is a small one right inside and a bigger one. Let's try to identify this first. Very important. If you look at triangle PBC, triangle PBC, that's a right angle triangle. And if you also look at triangle ABC, that's another right angle triangle. Consider triangle PBC. Let's try to sketch it out and see what happens. Let's sketch PBC out. This side is labeled M, this is labeled N, this is 60. If you look at this triangle, no side has been given. So it will be difficult for us to find any of M or N. But if you look at the bigger triangle, ABC, we'll notice that the length of the side AC has been provided as 20. Sorry. Let's erase this. Okay. The length of this side is given as 20. Now this is our M, and this angle is given as 30. We can quickly use SOH CAH TOA towards triangle ABC to obtain the length of side of this side labeled M. But once we have M, we can bring it here, and then we can now do what? Use triangle PBC to find the value of what? Of N. Let's look at how that is done. Here, looking at the bigger triangle, we can see that sine 30, this angle there, this side CB will be our opposite. This is going to be the hypotenuse, and of course the whole of AB will be the adjacent. Sine 30 is opposite over hypotenuse, and that is M opposite all over 20. Sine 30 is given as 1 over 2. So we have 1 over 2 equals to M over 20. We cross multiply. That gives us 2M equals to 20. Dividing both sides by 2 here, we have M equals to 20 over 2. And that gives us N. Now from there we can move on to PCB. This is our PBC, sorry. PBC. Our M is now given as 10. So we can solve for N. Since this angle is what? 60. We can look at this as our opposite, the given side or the known side. And then, since our hypotenuse is not going to be part of the game this time around, but the side N is the adjacent. So we're going to employ what? Tan. Tan 60 equals to opposite over adjacent. So let's see how that is used out there. So we can see that tan 60 is given as what? Opposite M all over adjacent N. That's the opposite, and that's the adjacent. Considering triangle PBC as a right angle triangle. M, of course, we have obtained as 10 divided by N. Cross multiply here, we have N equals to 10 divided by root 3. And of course, finally, we can do what? Rationalize this by multiplying numerator and denominator by root 3, and that gives us our N as that. So that's it for this video clip. Do not forget your special angles. Keep them close to your fingertips. I'll see you in the next clip. Very soon, we'll be rounding up with solving triangles.